Hi students, in previous sessions we discussed about current, drift velocity, current density and some relations we derived. Now our next concept is Ohm's law. What is Ohm's law? Before going to this, what Ohm said we will see. We can also say, but what he said first we will see. If you have taken one bulb, you connected a battery of 2 volts, first later you connected 5 volts, later you connected 10 volts. Let us say first you connected 2 volts, later 5 volts, later 10 volts. So for which battery this bulb will glow with more intensity? More intensity means more current is passing. Either 2 volts, 5 volts, 10 volts. If you connect 10 volts, it will glow with more intensity. Why? Because more amount of current is going to be passed. Now, if you are increasing the voltage, the intensity of the current, brightness of the bulb is also increased. That is nothing but voltage is always directly proportional to the current, or this current is nothing but potential difference between 2 points. Charge is going to be carried from A to B. Potential difference. This one either voltage or potential difference. So voltage or potential difference is always directly proportional to current passing through the conductor. This one filament will be there, filament will be coming to know conductor. So means potential difference is always, or voltage is always directly proportional to current. But whenever we are increasing this one, current is increasing means surrounding temperature should be constant and physical conditions should be constant. So why we said temperature should be constant, we will discuss in further topic. But presently, according to Ohm's law, potential difference is always directly proportional to current flowing through the conductor when temperature and remaining physical conditions should be constant. Remaining physical conditions means pressure, STP they will say, standard temperature pressure, atmospheric pressure, always, all those should be constant. This is nothing but Ohm's law. Ohm no need to say, we will be coming to know. Whenever we are increasing potential difference, current is going to be increased. This is the statement of Ohm's law. If we are going to remove this one, proportionality constant we will write. That constant only we will say R. R is nothing but here resistance. R is equal to V by I. Here R is called resistance. Same like the capacitance we derive. Q is directly proportional to V. Q is equal to CV. C is equal to Q by V. We to remember this one. This is nothing but we said capacity or capacitance. Same like that, this is nothing but resistance. What is this resistance? We will see. It is denoted by R. It is the ratio between potential difference and current flowing through this conductor. So one conductor you can take, this is nothing but a conductor AB. Whenever we are connecting this one for a battery, some amount of current is going to be passed. Then what is the resistance of this conductor means R is equal to V by I. We can find. What is the resistance? What is the resistance means it is going to oppose, conductor is going to oppose the flow of the current. That is nothing but resistance. The property of the conductor to oppose the flow of current. The property is called resistance. It is denoted by capital R. Another definition they will say the ratio between voltage and current flowing through the conductor is called resistance. Let us assume if you have taken one filament here. This filament is nothing but conductor. It is going to oppose some amount of current. Let us assume whenever you are connecting a battery, 10 amperes current is flowing. Whenever 10 amperes current is flowing here, all 10 ampere current it won't be yellow. It is going to yellow, let us assume 9.9 amperes. Remaining 0.1 ampere it is going to be opposed. That opposition property shown by conductor to the flow of the current is called resistance. This device, this conductor is called resistor. The device which is having property resistance is called a resistor, or resistor is a device which is opposing the flow of the current. Resistor is a device, resistance is the property. Like capacitance is the property, capacitor is a device. Same like that. What is the symbol of resistor? Symbol of resistor already you came to know in previous 10th class, 9th class somewhere. This is nothing but resistor. Again we will discuss about this one. Circuit symbol of resistor is that one. So now we will see resistance. R is equal to V by I. What are the units? What are the units for resistance? Voltage unit you came to know. What is the voltage unit? Voltage, potential, volt. Right? Current units, amperes, volt per ampere, or this one only they will write ohm. Ohm is the unit of resistance. Okay. Next, definition of 1 ohm. Generally we will be coming to know. 1 ohm definition means R should be 1 ohm, potential should be 1 volt, current should be 1 ampere. Resistance of the conductor is said to be 1 ohm when 1 volt potential difference or 1 volt potential is going to send 1 ampere current through that same conductor. 1 volt potential difference produces 1 ampere current through the conductor means that conductor is having 1 ohm resistance. This is the definition of 1 ohm. You can write the dimension formula also. How will write dimension formula means potential and current dimension formula you have to write. Current dimension formula is A. Potential means already I gave in previous lesson. We can do once, or work done by charge if you forgot means if you write you will be getting resistance dimensional formula. Okay, this is 1 ohm definition, and you have to write this resistance dimension formula by seeing what is the dimension formula for potential and current. In previous lesson I gave, once check and practice that one, dimension formula for resistance. Okay. So next one, conductance. What is the conductance definition? Very simple. Conductance is nothing but reciprocal of resistance. Reciprocal means reverse, 1 by R. R is here resistance. Reciprocal of resistance is called conductance. It is denoted by some books G. G is equal to 1 by. What is the unit of conductance? Units. 1 by, this is ohm, resistance units ohm. Reverse this one. Reverse means ohm inverse. This one only they will write like this. Mho. Ohm inverse or mho. Symbolically they will write like this. Ohm inverse or mho is the unit of conductance. What is the definition of conductance? Means simply the reciprocal of resistance is called conductance. Okay. So next concept, specific resistance or resistivity. Specific resistance or resistivity. In your books I think resistivity will be there. Another name of this one is specific resistance. It is denoted by rho. How it will be coming we will see. So resistance is always depends on length of its conductor. This is a conductor of length L1. Next another conductor of length L2. Another conductor of length L2. If you are increasing the length, then which conductor is having more resistance means which is having more length, that one will have more resistance. Resistance is always directly proportional to length of its conductor. Same like that. Resistance is inversely proportional to area of the cross section. Area of the cross section. A1, A2, A3. If you are increasing the area, the amount of resistance is going to be decreased. Inversely proportional to area of cross section. If you combine these two, if you remove this proportionality constant, we will write R is equal to rho L by A, where rho is called resistivity or specific resistance of the given conductor. Resistivity or specific resistance. How we will define? Rho is equal to RA by L. So they will ask define specific resistance or resistivity of the conductor. One of the year they asked this one for 1 mark question. So define resistivity or specific resistance. How they will define means rho is equal to R when Length is 1 meter. Area of cross section is 1 meter square. Resistivity or specific resistance is equal to resistance of the given conductor when 1 meter length and 1 meter square area of cross section. So the conductor which is having 1 meter length, 1 meter area, 1 meter square area of cross section, resistance only specific resistance or resistivity. Now resistivity of a conductor is equal to resistance, specific resistance or resistivity is equal to resistance of the conductor which is having length 1 meter and area of cross section 1 meter square. Understood? This is nothing but resistivity or specific resistance definition. What are the units? Units of resistivity or specific resistance. Rho equal to what is the equation? RA by L. Whenever you are forgetting or confusing units, if you remember the equation, you will be getting. What is the resistance we said? Resistance units ohm. Area units meter square. Length units meter. So 1 meter will be cancelled. Then ohm meter. Ohm meter is the unit of resistivity or specific resistance. Okay. Next, conductivity. Before going to that, see once here resistivity. I wrote units here. You can write dimension formula. Units ohm meters. You have to remember this one. Now we are defining conductivity. What is conductivity? Means the reciprocal of resistivity. The reciprocal of resistivity is called conductivity. Sigma equal to 1 by rho. What are the units? What are the units means? What is the rho unit? Rho means specific resistance or resistivity units. Ohm meter. Ohm means ohm meter whole inverse. Ohm inverse how we will write? Ohm inverse meter inverse. Ohm inverse we will write mho. Mho meter inverse. Like this also we can write. This is nothing but units of conductivity. Okay. Now we discussed about conductivity. Now see how to remember. You may get confused reciprocal of resistance or reciprocal of resistivity. Very simple. Conductance. Just how to remember. Conductance, resistance. Conductivity, resistivity. The reciprocal of resistance is called conductance. The reciprocal of resistivity is called conductivity. So tense, viti. This is how to remember conductance and conductivity because both are reciprocals. Okay, which is reciprocal? Reciprocal of resistance is called conductance. Reciprocal of resistivity is called conductivity. And how it is going to be changing? R is equal to rho L by A. If you have taken one steel wire or iron wire, if length is increasing, area of cross section is changing, then its resistance is going to be changing. But its resistivity is always constant. Why? Because it is constant for material. Okay, it does not depend on resistivity, does not depend on length and area. Okay, only resistance depends on length and area, but resistivity is constant. If you have taken iron wire, if you have taken 1 meter wire or 10 meters wire or 100 meters wire, its resistivity is constant, but its resistance is not constant. You should remember that one. Okay. Next one. Show that J is equal to sigma E or E is equal to rho J. They will ask for 3 marks question. Very, very important question. J equal to sigma E. What is J here? Current density. Sigma now only we said conductivity. E means electric field intensity. Okay. E is equal to rho J. Rho means here specific resistance or resistivity. This is another form of Ohm's law. Okay. So they will ask show that either this equation or this equation they will. For this we have to take. I told you these two are different forms of Ohm's law. According to Ohm's law, V is equal to IR. Here R is resistance of the given conductor. That is nothing but a conductor is having L length and area of cross section. Then R is, what is the formula? R is equal to rho L by A, because in this equation we will be having resistivity and electric field. And whenever we are applying this one, some potential difference. And what we are getting? electric field intensity in this direction. External electric field. What is the relation between V, E and L? We came to know. So we know that. So E is equal to V by L. EVD relation. This is third time we are using this equation. Okay. Then V is equal to EL. Another equation. We know that R is equal to rho L by A. Substitute V and R in equation number 1. Substitute V and R in equation number 1. Then V is equal to EL. Then R is equal to rho L by A. Very simple. All these equations already we came to know. So L will be cancelled. E is equal to I by A into rho. What is I by A? Current per unit area. That is only nothing but current density. E is equal to rho J. E is equal to rho J. If you control to 3 times, you will remember this one. E is equal to rho J. Rho J, we can remember. Rho J, if you remember, means rho J you will remember. Next, J is equal to 1 by rho sigma. 1 by rho into E. What is 1 by rho? What is 1 by rho? Reciprocal of resistivity. That is only. So J equal to sigma. This one very important for 3 marks. They will ask either show that J equal to sigma E or E is equal to rho J. In this we have taken Ohm's law. V and R we substituted, then you will get these equations. Okay.